Hello, everybody. How are you? I hope you all are fine by the grace of Almighty. Welcome to all of you at my today's lecture. This is my second lecture on Chapter 9 Atomic Model and Nuclear Physics. Outcomes of this lecture different atomic models, basically Thomson model, Rutherford model, and Bohr model. Our first discussion topic is Thomson model. J.J. Thomson researched the idea that atoms might be made of a combination of particles. He used cathode ray tubes to produce stream of negatively charged electrons or negatively charged particles from different elements, and he was successful to produce the stream of negatively charged particle using different elements. And he reasoned that all atoms must contain electrons. There are basically four findings of Thomson's experiment. All atoms must contain negatively charged particle or electrons. Atoms have no overall charge or charge of atom is zero. His concept was if atom's overall charge is zero or neutral, then there must exist positive charge inside the atom, which is equal to the charge of total negative charge. Only then an atom may be charge neutral. Basically, he wanted to explain that if the negative charge contained in the atom and if the overall charge of an atom is zero or that they are electrical neutral, then there is equal amount of positive charge inside the atom. And another groundbreaking concept about the shape and size of an atom were introduced by Thomson. He prologued that electrons are confined within the spherical atom of radius 1 angstrom or 10 inverse 10 meter. Thomson distribution of charged particle within the atom. Electrons are embedded within the continuously distributed positive charges. That means here his concept was the positive charges distributed here continuously and the negative charges are distributed discrete. And his concept he explained using a plum pudding model, as you see here in the first figure, that means the figure in left side. Here these blackish sheets there that are the plums, and this gray color, this is the pudding. And we see here these blackish sheets are discrete. That means here this one, another one as a different position, but this gray portion or the puddings are in continuous. That means these puddings are here as the positive charge and these sheets are here the negatively charged distributed over the atom. In the perspective of our country, this model can be compared with the watermelon. The juicy portion or the red portion we can consider here as the positive charge. They are continuously distributed here, and on the other hand these black sheets of the watermelon, they are distributed there. We can consider them as the electrons inside the atom. Our next model is the Rutherford model. Rutherford model basically depends on and is the explanation of the alpha particle experiment. Alpha particle is nothing but the positively charged helium atom. As we see here in this figure, that we used a radioactive source or the source of alpha particle strikes over the gold foil, and after the striking the alpha particle with the gold foil, the alpha particles scattered in different direction, and the majority of the alpha particles, they are not directed or the undeflected beams are here in this line, and these are the scattered alpha particles. And we must need to remember that alpha particles are positively charged. Findings from alpha particle experiment, experimental observation, and their physical explanation. As you see here, the majority of the alpha particles that are passed straight through the atom. That means we can say Since most of the alpha particle passed straight through the atom or the gold foil, most of the space of an atom is empty. That means the majority of portion of an atom is empty. And in the second term, a few number of alpha particles are returned back. That means here, just try to see in the third atom, this alpha particle just have turned back. That means we can say the alpha particle collides with some massive substance heavier than alpha particle. Today, as we know, the nucleus is quite heavier with respect to the overall mass distribution of the atom. And he introduced an idea of nucleus. And the third experimental observation, a few number of alpha particles are turned back and some are scattered from their path. That means in the first figure we see this alpha particle just have scattered from its path, and the second figure the scattering is quite larger than first one. That means we can say here, as we know, the alpha particle is charged positive, and it's only possible to scatter another positively charged particle if there exists another positive charge inside the atom. That means it's the scattering is the Coulomb repulsion only responsible for this type of alpha particle scattering. That means we can say there must exist a positive charge inside the atom. Nowadays we know the overall charge of the nucleus is positive, and especially the charge of proton is positive. Finalized atomic model of Rutherford. The first assumption was the center of the atom is highly concentrated mass. That means the center of the atom is the nucleus, and which is highly concentrated mass and positively charged. And this positively charged due to the proton. Today we know the proton stays within the nucleus. That means the proton charge is positive, then the overall nucleus charge is positive. The electrons revolve around the nucleus, and as the planets revolve around the sun. And the third one, the revolving electrons radiate energy continuously, so the energy of the electron will gradually be reduced, moving on a spiral path. As we see here in this figure, the high energy electrons stay at the farthest position from the nucleus, and when it revolves around the nucleus and it radiates its energy, and after radiating its energy, that means at the last of all, the electron mixed with or the amalgamate with the nucleus. And the later experimental or the theoretical calculation, it is considered as the major drawback of the Rutherford atomic model experiment. Let's go to our next topic. Our next atomic model is the Bohr atomic model. It's often considered as the quantum model. At first we need to know what is the quantum. Quantum means the discrete energy state. As we know, in the Bohr atomic model we consider here the discrete energy states or the discrete orbits rather than the spiral path or the continuous path in the Rutherford experiment, the Rutherford model. We consider here the discrete energy state of electrons to move or the revolve around the nucleus. Our first assumption was the electrons can move around the nucleus staying at certain fixed orbit having angular momentum. L is integer multiple of a is divided by 2 pi. That means our first term is to conclude here as the angular momentum. That means if any electron want to stay in the first orbit, that means the value of the angular momentum here L is equal to n a is divided by 2 pi, where n is the number of orbits. For the first orbit, the value of n is 1. That means L is equal to A is divided by 2 pi for the first orbit. As similarly, we can consider here for the second orbit, the angular momentum of any electron will be L is equal to 2 into A is divided by 2 pi. Simply after calculating, that maybe A is divided by pi, and similarly so on, go on. And our second assumption, electrons only can move around the nucleus in the orbits of fixed energy. When revolving in their orbits, electrons don't absorb or radiate energy. And this is the equation for energy levels or the permitted energy. En is equal to m e to the power 4 8 epsilon square n square a square, where h is the Planck's constant and n is the value of the number of orbits and m is the mass of electron and e is the charge of electron. And from this equation we can say here every orbits having a fixed amount of energy. And the last of all, the electrons can transform from one orbit to another orbit when it absorbs or radiates energy. That means one electron can shift from one orbit to another orbit. That means one electron stay in the first orbit. That if it want to go in the second orbit, then it need to absorb some energy or from the external source. Or if an electron stay in the second orbit, if it want to go the first orbit, then it need to radiate some energy. For simple case, if an electron moves from a higher energy state EH, energy of EH, to lower energy state energy of EL, then the energy of the emitted photon will be del E equal to EH minus EL. Del E means the energy of the emitted photon or the difference between the energy of these two states equal to higher energy state and the energy of the lower energy state. Okay everybody, no more today. Talk with you in the next class. Thank you.